All right, so here we're going to talk about using law of cosines. Again, law of cosines says that for any triangle, a side squared is going to be equal to the sum of the other two sides squared minus 2 times the other two sides times cosine of the opposite angle. And that's what law of cosines tells us. And basically what we're going to be able to say is that we're going to be able to solve for all dimensions given the other two, or the last two, congruence relationships for triangles. So we're talking about getting 3 dimensions again, just like with law of sines. And the last two set of 3 dimensions that define one triangle is side angle side and side side side. Now, we aren't able to get a ratio for law of sines with either of these 2 sets of dimensions, but we can use law of cosines to solve for triangles in this case. So right here, with side angle side, we're given 2 sides with an angle in between. So again, no opposite side to our angle, right? But in this particular case, what we're able to do is plug directly into law of cosines and get the dimensions we're missing. So in our first scenario right here, we are given a side A, a side B, and an angle C. And that means, of course, that we're missing angle A, angle B, and our side C. Right? Now, the easiest thing to do is going to be to solve for C, because right here we've really got the things that we would plug into law of cosines to determine what C squared would be. So right here we can say with law of cosine, C squared is going to be our A squared of 11 squared plus our B squared, which is 5 squared, and then minus 2 times our other 2 sides, 11 times 5, times cosine of the angle we have, 20 degrees. Now right here we can just type this into the calculator, and when we do that, we get C squared equals 42.63 approximately. And when we take the square root of both sides, we get side C as being of length 6.53. And again, that's approximate. I'm using an equal sign, but that's an approximate length for C. Now right here, we've got one angle, and all we really need is one more angle to use the fact that we know the sum of the angles of a triangle are 180 degrees. So what we're going to do right now is go through and solve for either angle A or angle B with law of cosines. And we're going to go ahead and solve for, why don't we solve for angle A? So right here, we know that side A, which is 11 squared, will be equal to the sum of the other 2 sides squared. So that's going to be our 5 squared plus our 6.53 squared minus 2 times the other 2 sides times cosine of the opposite angle, angle A. And that's what we're solving for here. So right here, we're going to get an equation where we can solve for cosine of A and then use inverse cosine to solve for angle A. So right here, we're going to get 121 for 11 squared, and then that's going to equal our 25, and then plus this number basically, 42.63, and then right here minus, and 2 times 5 is going to be 10, times 6.53 is going to give us 65.3 cosine of A. Now we want to get this sum, and we will have 21 equal to our, we'll call it 67.63 minus 65.3 cosine of A. We subtract 63, or 67 rather, 0.63 from both sides, 67.63. We get 53.37 equal to negative 65.3 cosine of A, then divide by negative 65.3 and divide by negative 65.3. And right here, that's going to give us cosine of A as equal to negative 0.8173. And now when we apply inverse cosine to both sides, we get angle A as equal to inverse cosine of negative 0.8173. And our angle A is going to be 144.81 degrees. That shouldn't be a big surprise to us in some ways, because right here we're asking inverse cosine to evaluate a negative number, and we know that that means for inverse cosine we're going to have an output of a rotation of something in the second quadrant, which is going to be an angle greater than 90 degrees, right? Because remember, inverse cosine takes the x values and gives us the angle measure. So we're looking at some angle measure in here. All right, so right here, we can say that we know our angle B then has to be 180 degrees minus the sum of our other two angles, so that's 20 degrees plus 144.81 degrees. And that is going to give us our angle B as 15.18 degrees. Okay, so let's take a look at this next one. I'm going to let you guys give it a shot. Right here, with this next triangle, we're given side, 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 which means we're solving for just the angles, right? So right here we're solving for angle C, angle B, and angle A. Now, in this particular case, with three sides, what we basically need to do is solve for the angle, solve for two angles, the same way we did right here. So it's a little bit of a long work, but I think you can do a lot of it in the calculator. And then go ahead and use the fact that the sum of triangles' angles is 180 degrees. So we would be able to basically say that last angle would be 180 degrees minus the sum of the other two angles. Now, as a tip right here, I would say solve for angle A and angle B, because it's nice to have 5 right here, so that we can say 2 times 5 and then get basically a bump up from the decimal. And that's a nicer number to get when you're dividing out. So right here, solve for those other two angles using law of cosines, and then subtract the sum of those angles from 180 to get that last angle. Okay, pause the video and give this one a shot. All right, so taking a look at this one. First, we can solve for angle A with law of cosines. We'd say that side A squared equals side B squared plus side C squared minus 2 times A times B cosine of A. I like to solve for these numbers, right? The A squared and then the sum of A and B squared, and then basically the coefficient 2 times 7 times 5. That gives me 81 minus or equals 74 minus 70 cosine of A. Subtract 74 from both sides, and then divide by negative 70, and we get cosine of A equals negative 0.1. And then apply inverse cosine to both sides, and we get angle A as being 95.74 degrees. Then we need one more angle before we can use the fact that the sum of the triangle's angles is 180 degrees. So solving for angle B, we say side B squared equals A squared plus C squared minus 2 times A times C cosine of B. Right here we get 49 equals 106 minus 90 cosine of B. subtract the 106 from both sides, divide by negative 90, we get cosine of b equals 0.63. Then apply inverse cosine to both sides, and we get angle B as being 50.7 degrees. And then right here we can say that angle C is going to be 180 minus the sum of the other two angles, 95.74 and 50.7, and that gives us an angle C of 33.56 degrees. So that's all cosines. We'll obviously see some work on the worksheet right there with that. We've got one more video to look at, and then you guys are all done. All right, so one more video.